On the 30th of July 2020, the Mars Perseverance Rover took off and will get to Mars on the 18th of February 2021. In this video we are going to look at the Perseverance's landing site, its objectives and what instruments it has on board the vehicle. Mastcam-Z is the name of the mast-mounted camera system that is equipped with a zoom function on the Perseverance rover. Mastcam-Z has cameras that can zoom in, focus and take 3D pictures and video at high speed to allow detailed examination of distant objects. The main purpose of Mastcam-Z is to take high-definition video, panoramic colour and 3D images of the Martian surface and features in the atmosphere with a zoom lens to magnify distant targets. The Mars Environmental Dynamics Analyzer is known as MADA. It makes weather measurements including wind speed and direction, temperature and humidity, and also measures the amount and size of dust particles in the Martian atmosphere. The Mars Oxygen In Situ Resource Utilization Experiment is better known as MOXIE. NASA is preparing for human exploration of Mars, and MOXIE will demonstrate a way that future explorers might produce oxygen from the Martian atmosphere for propellant and for breathing. The planetary instrument for X-ray lithochemistry is called PIXL. PIXL has a tool called an X-ray spectrometer. It identifies chemical elements at a tiny scale. PIXL also has a camera that takes super close-up pictures of rock and soil textures. It can see features as small as a grain of salt. Together, this information helps scientists look for signs of past microbial life on Mars. The scanning habitable environments with Raman and luminescence for organic and chemicals has a nickname Sherlock. Mounted on the rover's robotic arm, Sherlock uses spectrometers, a laser and a camera to search for organics and minerals that have been altered by watery environments and may be signs of past microbial life. Once Perseverance rover gets to Mars on the 18th of February 2021, it will be landing in Jezero crater. The diameter of the crater is about 30.4 miles. Thought to have once been flooded with water, the crater contains a fan delta deposit rich in clays. The lake in the crater was present when valley networks were forming on Mars. Besides having a delta, the crater shows point bars and inverted channels. From a study of the delta and channels, it was concluded that the lake inside the crater probably formed during a period when there was continual surface runoff. Ingenuity is what is known as a technology demonstration, a project that seeks to test new capability for the first time. Ingenuity features 4 specially made carbon fibre blades arranged into 2 rotors that spin in opposite directions at around 2,400 RPM, many times faster than a passenger helicopter on Earth. Ingenuity is intended to demonstrate technologies needed for flying in the Martian atmosphere. If successful, these technologies could enable other advanced robotic flying vehicles that might be included in future robotic and human missions to Mars. It also has innovative solar cells, batteries and other components. Ingenuity doesn't carry science instruments and is a separate experiment from the Mars 2020 Perseverance rover. Once on the surface of Mars, the Perseverance rover will conduct surface operations. Surface operations is a time when the rover conducts its scientific studies on Mars after landing safely. While exploring Mars during the surface operations, Perseverance finds rocks that formed in or were altered by environments that could have supported microbial life in Mars's ancient past. The Perseverance Rover is also able to find rocks capable of preserving chemical traces of ancient life, biosignatures if any existed. The rover will also drill core samples from about 30 promising rock and soil regolith targets and caches them on the Martian surface. The rover will also test the ability to produce oxygen from the carbon dioxide Martian atmosphere in support of future human missions. With the rover contributed to the preparation for human exploration of Mars by making significant progress towards filling at least one major strategic knowledge gap. The highest priority SKG measurements that are synergistic with Mars 2020 science objectives and compatible with the mission concept are a demonstration of in situ resource utilization technologies to enable propellant and consumable oxygen production from the Martian atmosphere for future exploration missions. Number 2. Characterization of atmospheric dust size and morphology to understand its effects on the operation of surface systems and human health. Number 3. Surface weather measurements to validate global atmospheric models. And finally, a set of engineering sensors embedded in the Mars 2020 heat shield and back shell to gather data on the aerothermal conditions, thermal protection system and aerodynamic performance characteristics of the Mars 2020 entry vehicle during its entry and descent to the Mars surface. Thank you for watching. I hope you found the video informative and are looking forward to the landing on the 18th of February 2021. Please feel free to subscribe if you like this content. This is Everything Space. Until next time.